now let's look at the compound interest formula. And this actually has more real life applications. This is more realistic for what a bank does to calculate the interest. So this formula is the amount is equal to the principal times 1 plus the rate divided by n, all raised to the nt. Okay, I know that looks like a lot, but it really is just a formula that we're going to use and plug numbers into. Okay, so don't be afraid. So A is the amount at time t. P is still the principal, aka the initial amount. R is that interest rate, still changed into a decimal. So interest rate, decimal. And then n, let's see, I'm going to put n over here because that's the new thing and I want to make sure we can read it. So n is the number of compoundings per year. So notice it says the compound interest formula. And then t is the time in years. So we're going to be looking at something for 5 years. So the time will be 5 still, but it will change because of this n. And so that's really where the change in the formula comes from. All right, so let's look at an example where we have annual compounding. So what this means is you have $1,000, you put it in an account. After the end of the first year, then you get 3% interest on that $1,000. That's $30. Okay, so now in your account, you have $1,030. Okay, so in the end of the second year, you don't just get $30, you get 3% of 1,030, right? So you're going to get a little bit more. And then at the end of the third year, they take the interest on 1,000 plus 30 plus the little bit from the second year. So every year your interest is going to go up because the amount that they're calculating the interest on is going up. And that's what's called compounding, okay? And I don't know if you've ever heard of that before, but it's like the power of compounding, because if you leave money in over time, the money grows, and so your interest keeps growing too. All right, so for annual compounding, that just means that n is equal to 1, right? Because the number of compoundings per year is 1. So we're going to say the amount is equal to the principal, 1,000, times 1 plus the rate is still 0.03. That's the 3% that we did before, divided by n, which is 1, raised to the nt. So 1 times 5. Okay, and so notice that we're just solving for a and we have no other variables. So although this is an exponential problem, it's not very hard to figure out the answer. So when you're typing this in your calculator, you actually can type it in all at once if you want to. I did put in the ones, obviously. I didn't have to, but for the other letters, we will have to. So I ended up with $1,159.27 dollars. So notice that you're going to want to use parentheses. And when if you use a caret, that's this button to raise the power, you're going to want to put that what's up in there in 1 times 5. Make sure those are up in the exponent, okay? So check your answer with your calculator and make sure you can get that. And I got the amount is equal to $1,159 $1.27. We'll just round to the cents, although banks actually round a bit farther than that. Okay, so notice that you got a little bit more than the simple interest. It's true, compounding does give you more. All right, for C, that's monthly compounding. Monthly means there's 12 months in a year, so n is equal to 12. Okay, so everything else in the formula is going to stay the same, except for the ones all become 12s. And you might think, wow, I'm going to get so much more money, right? But actually, you don't get a lot more, and you should, calculate this and find it out, because you're dividing that 3% interest over the 12 months of the year. So although you're now raising that to the 60th power, this number is a lot smaller. Okay, so here in this one, 1 plus 0.03 was 1.03 raised to the 5th power. Now this is 1 plus 0.03 over 12. So this number is not as large, not as greater, not as big. So although you're raising it to the 60th power, it's not that much different. Okay, so anyway, when you type that into your calculator, you end up with 1,161.62. So see, it's a little bit more, but like pretty negligible. All right, then finally letter D is daily compounding. So that's how many days are in a year. So we're going to use n is equal to 365 days in a year. So our formula becomes A equals 1,000 times 1 plus 0.03 divided by 365 raised to the 365 times 5. Okay, once again, the amount's not going to change that much, because although you're raising it to a really large number, you're also, it's really not very much more than 1 that you're raising to that number. And then you're multiplying it by that 1,000, so you're getting your final amount of $1,161.83. Okay, so we're getting pretty close to almost the same thing. Notice this only changed by about 20 cents.